Okay, so for example 2, we're going to use the same circle as in example 1, except we did one thing. For one, I labeled this center point, I labeled this D right here. So originally we had a circle with a triangle inside with the vertices at A, B, and C. Excuse me. What we did, or what we're going to do for example and exercise 2, is we're going to draw a radius from the center of this circle to this 90-degree angle C. Again, Thales' theorem tells us that if these 2 points are the diameter, they connect to any third point on the circle, and this point's called C, and that point will form a right angle. That's going to be true 100% of the time. What we did for example 2 is we drew an extra radius from the center to that 90-degree angle. So what that did, when we draw another radius from the center of the circle to the 90-degree angle, and then point C in this case, our one triangle turns into 2 isosceles triangles. So we had triangle ABC, that turned into 2 triangles. That turned into triangle ACD and then triangle BDC. We see the 2 triangles there, or at least hopefully. An isosceles triangle, just to remind you, an isosceles triangle is a triangle that has an extra pair of angles and an extra pair of sides. So what happens whenever we drew this radius here? AC, excuse me, not AC, let me scratch that off. AD and DC are going to be equal lengths because that's just 2 different radiuses, and the radius is the same across the entire circle. So DA is one radius, DC is another radius, so these 2 are going to be the same. And then DB is also a radius. So we have AD is equal to DC, which is equal to DB. And whenever you have a triangle with 2 equal sides, that means these 2 angles are going to be equal, and then these 2 angles are going to be equal. Let's run through this example and see how we can find some unknown angles and side lengths. So if the measure of angle, so whenever I write measure of angle DAC, that's this angle right there. The letter that's in the middle, that's the angle that you're looking at. So DAC. So I'm looking at this angle right here, the angle of DAC. If the measure of angle DAC is 50 degrees, so this is 50 degrees right here, 50 degrees. What is the measure of DCA? Well, it's an isosceles triangle, so the 2 angles that are connecting the radius to the center are going to be the same. So A is going to be 50, C is going to be 50 as well, because isosceles have an equal pair of angles and an equal pair of sides. If DAC is 50, then DCA is going to be 50 degrees as well. If the length, so you do not see the measure of angle, you just see DC. So that means it's a length. If DC is 12.5 centimeters, so from D to C, if that's 12.5 centimeters, what's DB? Well, this is an isosceles triangle as well. So if DC is 12.5, then this radius, DB, is going to be 12.5 as well. 12.5 centimeters. Okay, if the measure of angle DCB, so DCB, so this little piece right there, if DCB is 30 degrees, what is BDC? So what's this angle right there? Well, this is an isosceles triangle. DBC is an isosceles triangle, meaning it's got 2 equal sides and 2 equal angles. So if DCB is 30, then so DCB the measure of angle DCB is equal to 30 degrees. That means the measure of angle DBC is going to be 30 degrees as well. So the measure of angle BDC is going to be, well, if you remember, let me move this up a little bit, which hopefully you remember, triangles, all the angles add up to equal 180 degrees. We've got two of the angles, we need to find the third one. So BDC is going to be 180 degrees minus 30 minus the other 30, and that's going to equal, so 30 plus 30 is 60. The measure of angle BDC is going to be 120 degrees. Okay, exercise 2 looks just like this, except you have some different points. Let me move this down. You have some different different points are labeled differently, and they show up differently on the circle. But you solve it the same way. We have this triangle ACB. I drew a line connecting the center to the right angle, and then this formed two isosceles triangles. You have OC and OB are equal lengths, and then you have OB is equal to OA. The reason this is true is because these are all just radii, which is plural for radius. These are all radiuses, basically, of the circle, which means measure of angle A is going to equal the measure of angle OBA, and then OCB is going to, this angle is going to equal the measure of CBO.